Hi everyone, this is Mrs. Musoff here. Today we're going to be talking about performing function operations. Alright, now that sounds more complicated than it really is. Function operations are just talking about doing our normal operations, so addition, subtraction, multiplication, and division, but we're doing it with functions, so you might be seeing function notation, right? Remember, function notation is just the idea that sometimes you'll see instead of y equals, it'll say f of x equals, which just means the same thing as y. Alright, now if you've never watched a video and taken notes before in a math class, alright, my suggestion to you would be anything that I have written down already, I would suggest pausing the video and writing that down yourself. That way, you're not scribbling to finish writing stuff down and then missing any important stuff that I might be saying. Alright, so I would suggest pausing the video, write this information down, and then pick back up again, and you can, write with me from then on, or at least listen to what I'm saying in case there's something there that helps you understand it. All right. So the four operations that we're going to be working with are addition, subtraction, multiplication, division. And in general, the notation you'll see could just be, instead of saying do this plus this, it'll say do f of x plus g of x. And then we'll tell you what those two functions represent. Now, sometimes we use kind of a shorthand notation, and that's the one I want to get you a little more familiar with. That's this right here. All right, sometimes instead of writing f of x plus g of x, we just put in parentheses f plus g, and then have the x next to it. Means the same thing. All right, so don't get confused by these two different notations you're seeing. They really mean the same thing. I just want you to be familiar with both of them. Alright, when it comes to actually doing the operations, that's math we've done before, right? Not even just in this class, but in other classes too. So remember, with addition and subtraction, all you're doing is combining like terms. Alright, and if there are no like terms, that means you can't add or subtract them, so easiest problem ever, right? You'd be done. Multiplication would be like distributing. So you'd have to distribute everything in parentheses to everything next to it. And then division's the only tricky one, because the only way you can actually simplify division is if you can factor the two functions and then divide one out. Right? So factor and simplify. Right? And I'll show you an example of each just so that you can recognize it. Now, sometimes we'll be dealing with exponents too, and when it comes to exponents, then you would just use your exponent properties. So with multiplication and division, there is a chance that instead of distributing or factoring, you would just use your exponent rules, which we did in our last unit. All right, I'll go through an example of each so you can kind of know what to expect depending on the problem. All right. So let's scroll down and let's take a look at this first example. So again, I would suggest that maybe you pause the video so you can write this example down. And that way when you pick back up again, you can really follow along instead of trying to scribble everything really fast and then missing out on some important stuff. Alright, so this example, it says perform the given operations for, and then it defines f of x and g of x. F of x is going to equal x plus 3, and g of x is going to equal x squared minus x minus 12. So for part A, it says do f minus g of x. So that's really just saying to do f of x minus g of x. And so that's exactly what I'll do. I'll take f of x, I'm going to put it in parentheses to make sure I remember to use the entire function when it's subtracting. Alright, so I'm going to do the entire x plus 3, and then I'm going to subtract the entire g of x, so the entire x squared minus x minus 12. And for subtraction, that's really important because when we subtract, that means we have to subtract everything that comes after it, which means I have to distribute that subtraction. So I'm not just subtracting the first term, I'm subtracting the two terms after it also. Right. So in this first parenthesis, you can imagine there's like a 1 there, and when you distribute a positive 1, nothing happens. So that's why we can really just get rid of those parentheses. But in this second parenthesis, I am distributing this minus or this negative 1. And so that's going to turn into negative x squared or minus x squared plus x, and then plus 12. Because remember, a negative times a negative becomes positive. And this is the part where then I'm just combining like terms. So x is like terms with this x. Positive 3 is like terms with positive 12. and then negative x squared is by itself. I am going to write this in order. Remember, order means like highest exponent to lowest. So I'm going to start with the negative x squared. And then x plus x is 2x. And then 3 plus 12 is 15. And that's it. That's all I need to do, because all it asked me to do is subtract. So I'd be done as soon as I finish subtracting. A lot of people look at this and say, oh, so should I keep going? Should I try and factor it or something? But remember what the problem's asking you. It just asked you to subtract, so as soon as you're done subtracting, you're done. All right. Same kind of thing in letter B. Letter B says f times g of x, which is really just saying f of x times g of x. And remember, just a side note, anytime you need to pause to digest what we just went over, feel free to pause. Remember, that's the great thing about a video. And if you think of any questions along the way, just write them down in your notes, because remember, if you log on to Zoom during the assigned time, you can ask me those questions. All right? So we have f of x times g of x. Again, I'm going to use parentheses, so that's x plus 3 times x squared minus x minus 12. All right, this is the kind of problem where I'd have to distribute. Right? I have to distribute the x to the x squared, to the negative x, and to the negative 12, sorry. And then I have to distribute the positive 3 to all three pieces as well. Okay, remember distribute means multiply. So I'm really doing x times x squared, that's x cubed. X times negative x is negative x squared. X times negative 12. Negative 12x, and then I'm doing the same thing with the 3. 3 times x squared is 3x squared. 3 times negative x is negative 3x. And 3 times negative 12 is negative 36. And then once again, we're just combining like terms. So there are no other x cubes, but I have a couple x squareds. I have a couple x terms, and then my final number. And make sure you keep it in order. So I've got x to the third. Negative x squared plus 3x squared is plus 2x squared. Negative 12x minus 3x is negative 15x. And then the minus 36. And there's my answer. Okay. The only time it can get a little trickier is with division, because with division you have to remember how we divide when there are functions like this. So for example, this says g divided by f of x. That's just saying g of x divided by f of x. Remember, order matters, so if g comes first, that means you put g first and then f second. So here that would be x squared minus x minus 12 divided by x plus 3. And all you have to remember, this is, from last semester, and I know this is one of our more challenging units, so I completely understand if this part is a little confusing. That's why we're going to go over it again here. But in order to simplify division like this, you can't just say, oh, x and x, cancel them out. We're not allowed to do that. That goes against our math rules. So instead, the only way to simplify would be if you could factor either piece, either the numerator or the denominator, and then if there's an entire factor that's the same on top and bottom, that's what can cancel out. So for example here, x squared minus x minus 12. If I wanted to try to factor that, I'd be looking for things that would add to negative 1 and multiply to negative 12. So like negative 12, let's see, that'd be negative 1 and 12. Nope, that's not going to work. Negative 2 and 6. Nope, not going to work. Negative 3 and 4, almost, but that would be positive 1, so I'm going to switch it around, and that's the winner. So because I'm able to factor this, and it would turn into x minus 4 times x plus 3. Now, if there's an entire factor that's the same on top and bottom, then I'm allowed to simplify and divide those. So x plus 3 divided by x plus 3, that would just give us 1. And so I'd be left with an answer of x minus 4. All right. So again, most of this is familiar. I think division, that one could be a little trickier because I know at the time when we learned this, it was kind of tricky. But the good news is addition, subtraction, and multiplication should be super familiar, so that should make this a little bit easier. All right, you could just focus on that division. All right, the only other problems you might see are very similar problems, but instead of all this, addition, subtraction going on, they're just kind of exponent expressions. So 10x to the 7th, 20x to the 3rd, right? They just have exponents. And so these are the problems where we would really just use our exponent rules. All right, so for example, g of x divided by f of x, that would be doing 20x to the 3rd divided by 10x to the 7th. And so here we would use our exponent rules to help us simplify. Now 20 divided by 10, right, this part of the problem, those aren't exponents, those are just normal numbers. So I can divide those normally. 20 divided by 10 is 2. But then for the x to the 3rd divided by x to the 7th, that's where I use my exponent rules. And remember, if you're dividing, that means you can subtract your exponents, assuming you have the same base. Now be careful, if I subtract like 7 minus 3 and get 4, because 7 is bigger, there are more x's left in the denominator, so that x to the 4th should just be in the bottom. All right, and that would be my answer. Okay, so these exponent ones, we're really just using our exponent rules. Same kind of thing in letter B. G of x times g of x, that would be 20x to the 3rd times 20x to the 3rd. So again, the normal numbers, so 20 times 20, I can multiply those normally, that's 400. But then the pieces that have exponents, I would use my exponent rules. Since they have the same base and I'm multiplying, I would add my exponents. So x to the 3rd times x to the 3rd is x to the 6th. Okay, that's it. If you ever got an addition one for exponents, so for example here that would be 10x to the 7th plus 20x to the 3rd. Remember, in order to add and subtract, you need like terms. So is a term with an x to the 7th a like term with an x to the 3rd? No, those are not like terms. And since they're not like terms, I can't actually add them together, so this would be my final answer. Remember, our exponent rules really only work with multiplication and division. For addition and subtraction, you would have to have like terms. So if you don't, think of it as a short problem. All right, that's all for today. Hopefully these examples helped. If you haven't written them down yet, if you maybe just followed along for the video the first time, then just make sure you get a chance to write them down. And that way when you're working on your homework, you'll have something to kind of look at to help. All right, if you have questions, just make sure you write them down so that you can ask me later. Thanks for tuning in.